Back to another Drone Money podcast. You got your two hosts here, Harrison Knoll and Daniel Wyndham. Unfortunately, everyone, today Daniel is feeling a little bit sick, so we all need to have a little sympathy for him. And write in those comments, say get well soon.
Yeah, and just know that my voice is not always so silky and smooth.
It's not. Honestly, I had the same thing last week. It seems to be going around. Lots of people are getting sick right now. I didn't test positive for COVID, but I was very sick.
That's negative for COVID, strep, and flu. I just feel bad. The pollen count here is, I'm pretty sure, 1 million, as the entire ground is yellow here in Georgia. So it's probably that.
Probably that. That'll do it. Well, today, everyone, we are talking all about utility drone, LiDAR, and utility inspection with drones. So if you're tuned in today to learn a little bit about power lines, transmission corridors, distribution, generation, and how drones are really affecting those industries and really the details of how it's being done today, you're in the right spot. This is the place for you. You've made it. You're here. Welcome.
And big shout out to the group. We only started this, end of December? And now
how many?
Almost 4,500. I'm just going to say 4,500.
That's pretty insane. Thank you, everyone. Thank you.
It's a great group to be in.
It's a great group. And honestly, I think it's one of those things it's not even really about us. I see so much people communicating inside the group and sharing very real information, real valuable insights. And you can ask people questions and get real answers. And that makes me so happy because that's the reason we made the group. And that's what we wanted to happen. And to see it actually, the group growing up and being a productive member of society is just wonderful.
Our little baby growing up.
And so it's out there and people are using it. So
that's great. And it's always wonderful to connect with people that like the same things you do.
Yeah.
It's not exactly, your average neighbor down the street that's really into flying transmission lines with drone LiDAR. But hey, there's a few hundred people in this group that do that. So
yeah, that's really great. Well, let's kick it off. Let's talk a little bit about drones and utilities and inspection and monitoring and all the things that go along with it. So maybe we'll start off. I'm going to do a little crash course for you guys. So in case you guys don't know, so before ROCK and before Indiana Drones, I actually led another company. And what we did is we built out a whole utility program with drones. So we actually got paid a substantial amount in the ballpark of about $2 million to build out a program for a major investor-owned utility in the Midwest. And it was a 2-year program. And we had about, I think, 15 people in the team. And it was a kind of a private public, it's we were a company, but we worked kind of internally with our team to really establish how they use drones in their asset management plan. But it was really cool because what that opportunity gave me was the ability to kind of walk inside the utility through multiple departments, through vegetation management, through distribution, through transmission, through generation, through some of the admin stuff, and really, interview people in order to build out that inspection program with drones and how does drones really fit in and where do they fit in today and where can they fit in kind of tomorrow. So it was really
before 107 or during 107. What's the timeline?
This timeline was right at the beginning of 107.
Right then. Okay.
Yeah. So I think we started we were talking and trying to negotiate this contract prior to 107. So Part 333 exemption days. So right. 107, this is your license to fly here by the FAA for commercial purposes for drones. And so before that, you had to just get an exemption from the law. It was a very gray area. Right. We had a Part 333 exemptions, but yeah, I don't really.
Okay. Yeah. Back in the day.
It was back in the day, guys.
7
years ago. I don't know what this is now. Nice. But anyway, so yeah, I kind of want to talk to you guys about, what is the utility doing? What are their problems they're faced with? And then I can get into some real details. I have some pictures to show you too. So you'll see some cool examples. So basically a utility, right? You get this power generation. Obviously we all use electricity and we love it. I love it too. And one of the things, it's kind of broken down to multiple groups inside of a utility usually. And then before you even get in those groups, you have two different types of utilities. We have these investor-owned utilities, these IOUs. these are your big, huge utilities that kind of span states. They're very large utilities. And then we have a number of co-ops, and the co-ops is more of a community owned and operated utility. And the co-ops can be much smaller, and they typically service rural areas. So it's kind of your, segregation of the, investor-owned utilities, very big, powerful guys. But then you have lots of co-ops. And then inside of these organizations, what we have is multiple groups kind of that make up this, the whole infrastructure. We got the generation, and these are the people that are running the power plants. They're making the power. And then typically, usually you're going to have transmission. And this is like the high voltage power lines that transmit the power from the generation facility out to a community. And then once you get to the community, you have all these feeder lines, and all this goes into your community. And what you see in a lower voltage that goes to your house, and this is all distribution. So basically, you got generation, transmission, distribution, and that's typically going to be broken up into different departments inside the utility, because they're kind of servicing different needs, and they have different requirements that they have to operate under. And then all of it has problems. It was all built 50 years ago with a 50-year lifespan. And this is kind of the crux of the problem, why so much this drone stuff is playing such a critical part now, is because you have these assets that were built 50 years ago for the vast majority of assets in the United States. Vast majority is built 50 years ago. And then what you have on top of that is things that are built, 45 years ago, 40 years ago, 35, so you have this rolling thing going on where maybe the product that you can buy today on the market isn't the product you had 50 years ago. So now you got this whole issue of like, you got this infrastructure, it's aging, it's also built over time with parts that aren't always available. So it's a hodgepodge, right? So you have all this stuff that goes in to make it all work. And being able to inspect this in order to increase that lifespan, to reduce the risk of outages, this is the name of the game. Is like, how do we expand the lifespan of these assets and make them keep working? So that's kind of like the high end, you got these, that's kind of the makeup of utility, and then kind of the problems they're faced with. And then, in these problems, you got weather, you got ordinary wear and tear, lightning, you got, snow. Right now it's snowing a bunch in California. And all of these things are going to cause outages. And so we have building construction. So this is new field. We got the maintenance, and then we have like emergency response. And so all three of these things are like areas where drones can have an avenue into the life cycle of the utility. So I think with that, maybe I want to jump right into kind of a use case and get down to like a real actual core examples. And I'm going to break this down into two kind of categories. One, I'm going to talk about some inspection. So let's talk about just visual inspection and asset inspection. And in this, I'm going to talk most about visible. Thermal plays a role too, and I'll talk about that, but I'm not going to show any examples. And then I'm going to show some 3D analysis with LiDAR and kind of what that does as well. So first, let's jump into this visible inspection. And so let me share my screen, and give me 1 second. Boop-a-da-boo. So right now, this is a wooden H-frame. So this is a transmission line. So not all transmission structures are these giant metal steel lattices. And so that's kind of like if you look at Daniel's background, bring Daniel back on here, Curtis, because his background actually shows a very common type. Yeah, you can see him there in the bottom left, the left side. Yeah, that's kind of this big lattice tower. And so that's probably what rings in your mind for a lot of transmission. And this is the high voltage, transmits the large power amount down to different communities. But these wooden ones, these are also transmission structures. And there's a lot of these wood structures in the Midwest. And the reason why they do this is usually it's about the availability of materials at cost in your local region. So this was in the Midwest. There was a lot of trees. So the cost to build these was much less than doing the lattice ones. So that's why they're there. But so here, what I'm looking at is we want to be able to look at this asset. We want to be able to inspect the asset and make sure it's healthy. So what I've outlined here is 14 different kind of regions of interest in the inspection. And so we have these X braces, these cross arms. We have the insulators. So here on the left side, we have the insulator, and that's tied into the actual one of the phases of the circuit here. And then that goes to this cross arm, and then we have in the middle of these X braces, we have more insulators, we have more supports. And so all of this, so phase 1, phase 2, phase 3, and then we have this shield wire or this overhead ground wire that's on the very top. And so the shield wire on the top is basically an arrest for lightning. So if lightning hits this thing, it's going to ground out and short on this very top section. But then here you have 1, 2, 3. This is 3 phases of the circuit of your AC power system on the transmission. And so I want to kind of look through here and highlight a lot of different items that we're going to be looking at. And this is really, I'm giving you the use case of drones. And so the drone can come in here and take close-up photos of these assets that a human, it's very difficult to get out there and look at these things on foot. And so here's just a bunch of different things you can look at. So starting here at the bottom left, we have the shield wire wear and alignment. So on the top, it's basically just bolted in there. So you can really look closely and look at these bolts and see, is it attached correctly? Is it rusted? We have, the ground wire pole connection here in the middle. So that's running down the side of this structure, you see. So just looking at that, make sure it's there. We have pole caps. These are wood and they rot out from the top. And basically the pole cap isn't an immediate problem, but if it's missing, it's going to rot that pole and it's going to go bad soon. We've got these corona rings. Really, I think getting into these weight placements, static bars, snoot clamps, loose bolts. I mean, I think I'm going to talk just more in general in the design philosophy of this. The design philosophy of how you inspect it is really just going through very analytically and looking at every component and understanding where it can go wrong. Then how can I take a photo of that and verify it's not going wrong? And so one of the things that we'll focus on here for a second is just the insulators. And so here you can see an example of, this is like a GIS. And so in the background, it's basically a web map with photos attached to the locations that the towers are at. And so here you can see this is an insulator and you have all these bell caps and one of them is missing. And so this is a common problem with these insulators, is that one will just be gone. It'll get shattered. This happens for a lot of reasons. Could be lightning related, but usually you'll see flashover, and I'll show that examples. It could be someone shot it with a shotgun. Like, honestly, we're in the Midwest and this happens. People shoot shit with guns. And, the utility has to, like, these assets are out there for 50 years. Anything can happen. So to go out there and look at that and tag it. And so this is kind of the name of the game. It's like you want to get in here and make sure these look good, but then you also want to come in here and kind of look closely. So this is all examples of broken bells here. And then you have the bell cap on top. And so if I look closely, kind of what I see on this one is you see a bunch of rust on one side. Now that looks like it might just be rust, but if you see a bunch of black soot, and I think I might have a picture of this, excuse me. Yeah, you see like this down here, like you see this this fading right there. So this is the granularity of photo that you're trying to look at. And that right there is probably from some flashover. So basically an arc of electricity went over the insulator onto the line, or from the line into the pole down to the ground. And it's just, a big spark, and it leaves a little black soot, carbonization. And so you're looking for all these indications. And then I don't have a photo of it, but underneath each one of these, there's a cotter pin. So actually each bell is attached to the next bell, and there's a cotter pin that actually connects them. So making sure that cotter pin's there. And then similarly, there's a cotter pin also, if I have a good photo of one, yeah, here on this this boot, this clamp. So there's also a cotter pin on this. So that's what we're looking for. So when you come back and you're looking at these high, resolution photos and you want to zoom in, we're going to look at the actual hardware. We want to see, is that cotter pin there? We want to see, is the joint where you're attaching the wood to the wood, so you're on this X brace. We want to see, is that bolt going through? Is it worn out? Does it look like it's... So these are all the different things that you want to be inspecting in your visual inspection. And tagging it, make sure it's there. So I think that's a high level of view. Now, if we talk about thermal, so heat, one of the things that you want to be seeing is like If there's a lot of heat buildup, usually that means the power is going. So heat from electricity is because current is going through a highly resistive material. And if you're going unimpeded, there should be a uniform heat signature. But if now all of a sudden it's getting impeded and maybe it's arcing and going down into the ground, it's basically that would be going through something that's getting heated up and it's high resistive. And so that's what you're going to look for a thermal. So let me jump over and end it there. So we can come back to this later. I'm going to get off my soapbox for the visual inspection and then get back on my soapbox for the LiDAR stuff.
Sweet.
Okay. This is
Do you feel taller when you're on the soapbox? Because you're already tall.
No, I just maybe, I don't know.
If I got on a soapbox, I still would not be as tall as you.
Did all that stuff make sense? Am I just ranting over here?
Yeah. No, we're not live yet. Don't worry about it.
We're not live. Okay, good. No one saw
that.
No,
that's really enlightening to me because I haven't really done any of this utility stuff.
Mm-hmm.
But it makes sense, and you can tell the volume of assets just on one transmission tower. Across thousands on one line times hundreds of lines, even just for one provider. So there's no way that they can take a look at it in the traditional sense.
Oh, it's not happening. It's just not happening.
You can't get good enough resolution really from like a plane. Like they use helicopters and stuff like that, but that's super expensive.
They do use helicopters and they do the LiDAR stuff.
Mm-hmm.
And the regulations basically like you need to have it's a 30-degree angle inclination
Mm-hmm.
of your camera taking a photo of the whole structure. And that structure must
Mm-hmm.
occupy 80% of the photo. And the photo has to be like 20 megapixels. This was like the requirement that they gave us. And that's what, when they would hire out a helicopter, that's what they were doing. But like 80% of a 20 megapixel photo, we're only talking about 16 megapixels. Can you see a counter pin in that?
And so see an insulator.
We have our guest is actually DMing us right now. He says still the requirements. He's going to talk more about this. So let me talk about LiDAR for a second, and then let's talk about our guest that's going to come on today, who has a lot of experience, who's doing this today. So I may be dating myself about the knowledge I have, but Noah's doing it today, so he'll be on in just a second. Let's talk about LiDAR, and let me share my screen and bring up the this LiDAR data set. If you all just bear with me. So on the other side of things, so we have the visual inspection, and now let's talk about 3D inspection with LiDAR. And so here I have a circuit power line, and it is cutting through a neighborhood. So this is basically flown down and back. That's all this is. This is an R2A LiDAR system from ROCK, and it's flown down and back. And then what we've been able to do is classify it. And so you see the red, this is actually the 3 phases of the power line. And then we have the tower here. And then obviously those are trees. And what you're seeing around the trees, these are basically encroachment regions. So we're able to classify the data and then see the encroachment of the trees to those power lines. And this is I'd say level 0. So level 0 is just encroachment today, what it is right now. Mm-hmm. And so is it touching now? And this is very useful. You can see the use. Obviously, California's had a bunch of wildfires from trees touching wires and then catching fire. And then the next level of things is starting to look at things like fall in. So if this tree were to fall over, so how many trees do we have in these risk categories? And so one of the cool things is that you can basically now using software get a lot of this information for you. And so you're able to just fly it, upload it to a software, and then get the analysis back to make decisions on. And then what this is end up doing, so you see all these little light green, lime green squigglies, those are actually shape files. These are actual vectors around those encroachment areas. And then you can see here on the map view, all of this is you can see on the map view here, but you can import it directly into your GIS software. And that's what utilities are doing. They're going to go and look at all that encroachment, map it with LiDAR, calculate the encroachment. At the end of the day, though, they're going to be looking at a map that has some squiggles on it that says, go cut tree here. And that's really all they need to know. And putting it in perspective, vegetation management is a huge budget line item of the utility, because I don't know if you knew this, but 50 years, trees can grow quite a bit. So, you got to cut that stuff.
Mm-hmm.
So I don't know, Daniel, isn't this LiDAR data set though, just in general, just stepping back from talking about what it's used for, I just think it looks so pretty.
Well, think about the detail too. I mean, that you can those wires aren't that big on a distribution line, and they're covered up with trees by their very nature of having to have trees removed. So, I mean, you got all kinds of layers in there. I love seeing all the classification.
I know, me too. I want to zoom out, look over here. You can see this. This is I flew this. This is something I flew. I flew this whole thing, and I think it took me like 2 hours, something like that. It only took me 2 hours because there was so many trees I had to relocate to like go and get the different areas. Yeah, visual line of sight was kind of difficult on this. I'm turning those trees back on.
Look at that. And you've got custom classifications in there too, right?
Yeah, these are all, you see tons of classes, right?
Mm-hmm.
Yeah, you can even see, here the transmission line cuts out, and then we have so here's something else. So just so everyone knows, like when you look at a line, you see some wires are really high in the air, some of them that are kind of close to the ground, and oftentimes you'll see the ones that are kind of close to the ground, they look all jumbly, and you got a bunch of bird's nest going on there, and those are all your communication lines. So those are like low voltage, like that's not going to cause a fire, and typically it's like your local cable TV dude who's just like bolting stuff up there, and just like, so there's multiple entities actually attaching crap to these assets. Yeah. But you can see here,
my local EMC, they had internet installed, and there's just bulk wire on all these different poles, but it's 5 feet above the ground. It's fiber.
Yeah, I don't know. We can come back to this, but let's I'm gonna stop. Yeah, it looks pretty cool. What do you guys think? Ask some questions about this. I'll keep this data set open for later, so that way we'll get to your questions if you have any questions about the data set or back into the visual stuff. But why don't we go ahead and move it over and talk a little bit about this? We have a new use case, I believe, that Curtis published in ROCK. So we have a pretty cool use case story. So if you guys want to learn more about this and read after the video, and you can come and look at this use case, I think Curtis is going to share it here in 5, 4, 3.
Look at that.
That was a very Wayne's World moment. In 5, 4.
Oh, I forgot the hand.
Wayne's World. So case study using ROCK LiDAR to inspect power lines across California. So we have an awesome story here about Surefire, and that is the name of the company, and then Noah Carr is the person. So Surefire has been using ROCK for a few years now and been an awesome customer. We really, really like working with these guys, and they do some really tremendous work and have just grown tremendously actually in the past couple of years. Like from what I've heard, I'm obviously not internal to their company, but I think we should actually bring on Noah Carr and ask him those questions. So why don't we bring on Noah?
Hey guys, how's it going?
What up, Noah?
Thanks for having me.
Absolutely. Welcome to the Drone Money Podcast.
Yeah, happy to be here. Excited to talk about LiDAR and power lines and drones and all the good stuff.
So for everyone, this is Noah Carr. He works over at Surefire, and he has been doing utility mapping and inspection with drones for how long now?
Well, specifically with the LiDAR, it's probably about 3 years now. Drones in general, almost 10 years. I've been doing it for a long time. Kind of turned it from a drone hobby into a career. So fortunate to be able to, I feel like a lot of us in this sphere, to be like, okay, something I really enjoyed doing, be able to turn it into something that makes money and I can live off of. So it's pretty awesome.
Totally. So why don't we go ahead and kick off this section with Noah here. And, I'm really happy to have you on the show. It's awesome. I think a lot of people watching right now are going to get a lot of value from listening to you. You have a lot of experience and expertise, both just, doing it hands-on, but now leading. So both in manual, I went and did all this stuff, but also now I'm kind of your project managing a bit now and kind of leading larger initiatives and kind of hearing that story. I think it'll be really cool for everyone watching. And then, but also just understanding about where you're at right now. So could you share with everyone where you're at, what the company you work for, and what does Surefire do, and what do you do there?
Yeah, so I mean, Surefire is the company I work with. We are a QA QC company primarily. We do utility inspections for major utilities all throughout California and across the United States. And I kind of came into the company about 5 years ago, and we started a drone division. And so that drone division now does utility inspections as well. Anywhere from what you were talking about earlier with visual inspections with cameras to all that hardware and everything to thermal inspections of the hardware, substations, everything like that. And then also majorly here is the LiDAR component of it. And so kind of Surefire was founded back in 2006, I believe, and really on the basis of doing the utility inspections because it was all in-house with the utilities initially. There wasn't really any third parties doing it, and it kind of was a conflict of interest. So that's kind of where we come in, is trying to bring an unbiased perspective with quality people who know what they're looking at. A lot of the guys that work for us are retired linemen. They're all union that come from the union halls.
That's awesome.
So we have the experience of what we're doing and looking at these, lines were involved a lot with new construction, not just existing stuff. So, for example, I was out on a project a couple of weeks ago. They're building a new 600 kV line through Los Angeles, and we're out there inspecting all the hardware that you're discussing at the beginning of its life. So we were kind of looking at stuff that was at the end of its life. We look at it at the beginning of life to make sure it's installed correctly. For the longevity, make sure those cotter keys and bolts don't come loose. There's really specific ways in which those are supposed to be installed, actually, as to prevent further issues down the road for when 50 years when you're coming back with the drone looking like, oh shoot, that's falling apart. The goal is we look at it ahead of time and hopefully mitigate those types of things.
That's awesome. I mean, and that probably wasn't even done.
Oh God, no! You look at some of the stuff from like 5-10 years ago. It's cotter keys are upside down, backwards, bolts are facing the wrong way, and stuff like that. So that's really the goal, is to really try to help the contractors and the utilities to produce a better quality product.
And Surefire, you guys, what's your service area?
So we have 2 locations in California. We're down in Temecula, which is just north of San Diego, and then we have a location up where I'm at in Sacramento. But we service all across the United States. We've done work all the way over in like New Hampshire, on the East Coast. So we go all around and do work for everybody. But right now our main hubs are in California.
Yeah, you guys are crushing it too. From everything I keep seeing and hearing from you. I mean, Noah, you and I have been talking for a couple of years now, and I've been watching you guys just kind of steadily and consistently grow and broaden your offering. And I think really like what you were saying. So Surefire having a wealth of knowledge with the linemen, so linemen, these are the guys inside the utility that were out there actually doing the maintenance, doing the inspection, doing the installation. But having that on your team provides you with a wealth of knowledge that what to look for and how to look for it.
Exactly. Yeah. So and then that's really where the value of the people we have looking at the data is, and then we're able to provide another value on the front end of how we collect that data, whether it's from the ground or with drones in the air. So it's really trying to hit it from both fronts of the quality of the history of the old school line of ways that linemen are doing things, but also the new school way of collecting data and really bringing that efficiency to everything.
Can you tell us a little bit about how you guys are collecting data today, and like what does that look like inside the company?
Yeah, so I mean, it's 2 ways. Like it's from the ground. A lot of the guys are on the ground or there when the stuff's being built, so they have cameras that they utilize from the ground. And then once stuff's finished and we got to do large volumes, we use drones to go across and collect that data, just like you were looking at that H-frame. There's really a nuance to actually collecting that data because of the way that things are installed now. You have to be aware of the way the hardware is facing. You want to be more efficient. You don't want to go out there and take a picture of a bolt, but it's the head of the nut. It's not where the cotter key is on the inside. It's a useless photo. So really understanding how hardware is installed and then actually being able to go out and capture that efficiently is super important. So we're doing both, LiDAR, visual inspection, thermal inspections, and then from the ground. So we're doing,
and then when you capture that data, like what are you guys putting in GIS, I assume, or? Yeah,
GIS, we're mapping it and we're using it to locate, and then we're attaching those photos. We utilize a couple of different softwares. We're still, data is a huge thing for the utilities. That's the hard part, is when you're going out and collecting, they're like Daniel said earlier, you're collecting, say 15 images per photo. Now that's on a low side, or per tower. That's on a low side. And you do that for 500 towers, because
Yeah,
that's
it's a lot
a lot of images.
Yeah.
And if they're just in files, it's super hard to be like, okay, which one's the correct photo and what is actually actionable data. So that's the real challenge for the utilities is transferring that data that you collect into actionable data, and being able to classify that to where it's like, okay, this is an issue, but it's not really an issue. So the utilities aren't getting overwhelmed.
Yeah.
And I think that's one fear of a lot of utilities. Oh, there's too much information. I'm getting scared. This is too much work for us.
Well, it used to be out of sight, out of mind. We'd know when it stopped
working. That used to be for some people
yeah,
still.
Yeah. It still is. That's kind of the problem. And that's where the expertise that we have comes into play. It's like, okay, we know what's really going to be an issue, what's not going to be an issue, what may potentially be an issue in the future. And we can classify those on a level of like really high priority, medium priority, low priority. And stuff like that.
Even whenever I was doing this project, not every even asset they had was even in the GIS yet. They had like a team of like 8 people just taking stuff from the real world and putting it into their GIS, an online map. And so like we were out there inspecting some assets that weren't even on.
Yeah. Well, a lot of it is they don't have drones before. So a lot of places are really hard to access by foot. Or impossible to access by foot.
Yeah.
So the drones are really able to get you into spots that you typically can't get into. And it allows you for more information.
What about like timelines? So I know like one of the things that, I was going up against with the utility is like, they did LiDAR and they did these 20 megapixel photos. And so like that was kind of like they did it from helicopters. Yeah. And but the timelines that we were talking to, because I was talking to like the head of vegetation management at the group I was with, and he at his desk, he had a pile of hard drives. And so they would literally go out, the country would go out and fly. And he was like, it'll be like 6 months before we get data. And it's just going to be a hard drive that they give me.
Yeah.
And so like, that was like almost like a 6 month to even more than 6 months turnaround from going out to like getting like,
that's the big thing. I think they've gotten better, at least the utilities we're working with here in California. I would like to say, I think California in terms of where they're at is a little bit ahead with maybe some other places in the country.
Yeah.
So visual data, I think they're a little bit past hard drives on desks now, but I'm hearing that with LiDAR data, it's still 6 months to a year after a project is completed that they're not getting data. So that's one thing that we strive for is getting actionable data in their hands quickly and efficiently. So we go out there, fly a line, we try to have it back to them within a week or two.
That's crazy fast. Like that's the scale going from 6 months to a year to like a week or two.
Yeah, it's crazy. It's unheard of from what they're, and that's the reason why we're able to get in the positions we're in is because we're able to produce that data so quickly and efficiently. And quality. The quality of the data is, if not the same as a helicopter, if not better than what they're getting or what they've had, because the data they have is 7, 8, 10, 15 years old. Yeah. Super out of date. It's super low res and low quality. So even though we're using R2A, which may not beat a $200,000 sensor, but it'll beat anything from 5 years ago that was $200,000. So
you don't have to wait 6 months to get the data.
Exactly.
Yeah, totally. I think that the whole game has changed, and definitely like doing the drones for inspection. I don't know what the kind of the questions are from the people watching this and what they want to know. We'll get to them in a second, but I could assume just understanding like that drones are being used and they're being used very effectively. I think it's just one thing that's like really exciting. And then like obviously we got regulations kind of holding us back, right? So there's visual line of sight, which really is just very challenging, especially when you have a utility corridor. That thing ain't going nowhere. Like you should be able to fly over this thing repeatedly all the time. I think that's the future of where it's going. And I think we're very we're on the precipice. Maybe in 5 years, it's going to be very
We're
routine.
right there. Yeah, we're right there. I think with the type of drones that are being put out now in terms of the base stations and the docking stations, and then also the the availability of just the way that they're doing inspections. I think we're close for sure.
Well, just can you imagine having like I know so in the Midwest, I'm from St. Louis, right? We had lightning all the time, and like a tornado comes through or lightning, and if you're a linesman going out there in the middle of the night to respond to an outage, and just being able to have a drone that already flew and showed you where that wire was down on the ground, and you knew not to go step on the damn thing, like just safety, like just I think that's so big, and I'm really excited for that to be a reality. It will be a reality.
I think
Put
so.
it put it this way. Yeah, I did a lot of work in China. So actually, I built this. I worked to make this VTOL LiDAR system, and it was like a team of like 6 Chinese dudes went out and they flew this VTOL with a big Regal LiDAR in it, and they inspected. I think like it was like 100,000 kilometers of lines,
Oh,
and
wow.
like they just did it in like a few months, and it was just a 24-hour operation. They were just going, but like it was all BVLOS. It was all, so it's like the model's there. It can be done.
Yeah.
We know this, and like it's exciting to see how we're gonna do it, and like
Yeah.
people like you are gonna be at the forefront of
That's the
getting these
goal.
contracts.
Yeah. I mean, right now, I mean, we'll look at one of the data sets that we're going to discuss, and the challenges that come by with having to be one within visual line of sight, but the terrain and different stuff like that really introduces different challenges. And, it's a whole different set of skills and things you have to adapt to that you may not be expecting when flying the LiDAR and everything. So,
Noah, can you share with us a little bit about your background? Like, how did, like, you as a person, where'd you come from? How did you get into this?
I came from my parents. That's where the start is.
Yeah.
But no,
it's only so long, Noah.
Right.
At least start in elementary school.
Yeah. We'll start way at the back, way at the beginning. No, so I mean, I kind of my start was I grew up, high school, really got into drones and really enjoyed and saw a future in that, and kind of thought that there was an industry for it even back then, and pursued it a little bit and did some different small jobs here and there. Enjoyed it, but ultimately was like, okay, I got to find a career. It was a hobby. It wasn't a career. So coming out of high school, I had a full-ride scholarship to a college. Ended up not deciding to go there. Ended up deciding to go to lineman school to do trade. So actually kind of work exactly in what we're doing. So I went there, I completed lineman school, and then went and worked with some of the utilities for about a year. Really got experience hands-on with a lot of the stuff we're working on. That's kind of where my experience comes from, is actually, working with these lines. I've climbed one of those, that H-frame that you showed. I've climbed them. Those insulator belts, I've installed those. So I know what it looks like, what it's supposed to look like, and kind of really adds a little bit more expertise or diversity to what I know. But after a year, I was like, you know what, screw this. This is not what I want to do with my life. I don't want to be climbing poles and out in the rain and the snow and traveling all this, every single week for months on end. It just wasn't the type of lifestyle I was looking for. So I ended up going back to school for electrical engineering and needed a job. So I started working at Best Buy. And lo and behold, after a few months working there, I sell a TV to my now boss. And we just started talking about drones, and he was looking for somebody to hire. And my pitch to him, I think I have the PowerPoint still, was how drones can be used in the utility industry for QA/QC inspection. I had LiDAR on there, I had visual, I had thermal. It's like I saw it there. I was like, it was just crazy.
The boss walking in and finding like the Best Buy guy is also just a lineman.
It's crazy.
Drones,
at Best Buy too, is you walk up to somebody and you try to sell them a TVs. I had to be the one to walk up to them. Somebody else could have walked up to them and try to sell them. And so, I'm very fortunate. I'm very grateful for the position I'm in now from where I was. And kind of how it happened. It's like one in a million. Like I don't think that would ever happen again to me. It was kind of a very lucky thing. I'm very grateful.
Fate, but you put yourself out there and you made it happen. Honestly, like I think, you shot your shot and you won.
Shot. I made it. It's great.
Yeah.
So I worked for Surefire for about 2.5 years, doing just other things, kind of learning the company and learning how things are run and the systems, the QA/QC side of things. And then a couple years ago, the owner, Frank Flores, great guy, he said, you know what, we can start that drone division, and you're going to be the head of it. So I've been able to do all the procurement. Harrison, we got in contact with you early on with when the R2A was, I kind of think, first rolling out, right?
Yeah, very beginning.
The early stages. You guys were great. We got the system, and it's kind of been running off from there. I'm very fortunate, it's the lead pilot. I still pilot from now, now and again. And I'm running the team. I'm running this big project from each utility up here, where we're on 15 different projects within the utility, doing LiDAR drone inspections on every single one of them. And kind of just expanding. It's been going really great. So it's awesome that I was able to turn a hobby from high school to now a career that I actually do enjoy and, want to come back and work to do every day instead of work before. I was like, this isn't for me,
Right.
So yeah, very
that story is being told by so many people right now across the U.S., across the world, probably. It's like, just because 5 years ago, it really was basically a hobby. Like,
it didn't exist.
Yeah.
You had to make the program. You had to make.
It was from scratch. It wasn't there.
Yeah.
So yeah, no, it's cool to be in the forefront. I think, and even 2, 3, 4, 5 years now, I still think it's the forefront. I think we've only scratched the surface of what we can do. I think we're definitely getting closer to the mainstream and really being what it's really worth. But that mass adoption still isn't there. There's still a lot of utilities, a lot of contractors that don't use it. That it's a really big thing that I think is going to get even bigger and bigger as we go.
I talked to someone recently, and they basically just every lineman they have, they're making them get 107, and they give them a drone.
Oh wow.
Yeah, so like every.
I don't want to hear that. That's going to put me out of business. I don't want to hear that.
No, I think that's just like spot inspection, right? But I think
these are Mavics, not LiDAR flying around.
No, it's smart because those things now are super user friendly. You can throw them up; they can get high quality images. As long as they're trained properly, you just want to risk them flying straight into a line and okay, there goes there goes the power. But
I was gonna say in that project, what we did, one of the things we were like testing, like what does a drone do to the power line? Like what could it do? And honestly, like I don't know, like not.
I actually I was at a conference, it was Distributech. It was maybe 3 weeks ago, and I had an engineering company ask me, they're like, "What can you tell us a drone will do to the power line?" I was like, I have an electrical engineering background and stuff. I can't tell you. We don't really know. There's been tests, but electricity is so unpredictable. It could cause a problem. It could not. I'm not going to sit there and be like, it's 100% safe. We're all good to go. I'm not going to be the person to do that. But we can put policies.
Let me be clear. I'm not saying that either.
I don't think anybody should.
No, but one of the things that we did do, they gave us a bunch of insulators. They gave us some glass bells. They gave us some ceramics, and I just sat there with a hammer, and I had this hammer, and honestly we bent the hammer.
I'm sure those things are durable. It's very durable.
I was like, dude, this Mavic isn't going to do crap to this thing. Like,
the carbon fiber is not going to touch it.
It's like they're strong.
They're very strong.
But
they're very strong. They're well built.
They're well built.
It's the power side of it. They're less worried about the insulator cracking. They're more worried about the power going out and people losing power. That's the main pushback and concern we've heard. Which is
the amount of money that every minute of a circuit being down it's pretty unfathomable. Like
it's crazy.
Yeah, when you look at because we had to also they were talking about us getting insurance in case something did happen, and they were talking about liability, what could we be liable for, and it was every minute was millions of dollars, and it was
there's utilities. That's one barrier to getting into it is insurance. There's some utilities that want you to have $10 million in aviation insurance, just in case, and that's what they require the helicopters to be at. It's like, okay, if we crash into something, we're definitely not going to cause as much damage as the helicopter. I'll tell you that much. Right. That's the hard part. That's a barrier to getting into the utilities. Is the insurance is pretty crazy.
Yeah, no, definitely. Why don't we? So you have a data set and an example you wanted to share with us today?
Yeah, absolutely. Do you guys have that up or do I need to pull that up?
Curtis?
I believe
Curtis is off screen, everyone.
1, 2. Let's see if I can get it this time like you guys did.
Yeah.
Go. Nope, I'm off. It's that I'm new. I'm too new. No, Curtis and I don't have that.
It was performed though.
It's the symbiosis. Yeah.
There
we go. Telepathy.
Yeah. Yeah. So what do you want to go over here? We can kind of just discuss it and go through it.
This is cool. So what are we looking at here? I know what we're looking at, but
LiDAR. So this is right. This is one of the projects that we were on for this big utility that we're working with up here, and kind of out in a rural area up in the hills. It's kind of hard to tell, but that elevation gain on the left side, I think, is about 500 feet and a quarter of a mile, so extremely steep. And the goal or the plan coming out here was just to drive up to that peak and fly it, pre-map it out, good to go. But it had been raining for 3 or 4 days straight, and it was basically just straight mud on the side of that hill and trying to
Yeah,
walk
get
up
up
in
there.
between those towers. Couldn't
Yeah.
get up. It took about 30 minutes to walk to the top of that hill. 30 to 45. I think it took me 2 hours to get back after going back down one end and then back up the other.
Yeah.
But just uniquely challenged because you can't take off from one side of the hill because one, you lose visual line of sight. So then you're not compliant with FAA. And then two, you're going to lose connection because it's a giant hill and your drone's not going to, have any connection with, either your GCS or your controller, whatever reason.
Are you using UGCS still?
We're still using UGCS. I personally like it.
Okay.
I know that the DJI Pilot 2 has their new terrain follow and everything, but we have to be really precise with our maps or to get proper overlap, and really got to make sure that we're going over the lines perfectly, not perfectly, but close, in order to get those really good details. Because if you fly perpendicular to a line, you're not going to really capture it as well. You need to fly parallel with that line. And then we also have specific requirements for widths and distances between different.
Yeah. What are you finding? Are you flying like just right off the left side of one wire and right off the right side? Or are you basically go over the top, like when you're looking?
So for something like, we're typically doing 3 to 4 passes. So if we have 2 towers like this, we'll do 4 passes. So we'll do one off of the tower about 30 feet, do one pass. We'll do another pass straight over the top of one of the towers. Next pass will be over the straight at the top of the next tower. And then 4th pass will be coming back, will be on that outside. So we got to make sure we get about at least 100 feet, 150 feet outside of the farthest line.
That's to get the whole right away on the left and right.
Correct. Yeah, we got to make sure we capture all that.
Yeah.
But yeah, so here we had a hike up to that midpoint. So I had a drone strapped onto me with the controller, or not the drone, sorry. I had the controller with a backpack. I actually had a Phantom on me just to do scouting. So I had a Phantom backpack on. That's laptop, sweet. UGCS all hooked up, and we actually had the drone down at the bottom of the hill. Curtis, we flipped to the other side. That's where we kind of took off from. And so I took off. I got up to the top of the hill, and I took off from the top of the hill, controlling. Did our stuff. Big challenge.
Section. Did you fly? There's more to this than just this, right?
No, that's it. So for this stuff, it's really just, that's why it's so cost effective for what we're doing. Is we're just doing small new constructions. They just replaced that one tower at the top of the hill. They don't need to go fly the whole line, right? So where we're coming in is doing these small sections where for a helicopter to go out and fly that, it's going to cost them, $6 to $10 grand just to get the helicopter up in the air. Right?
Just get in the air, and then the data's not going to come back to you for.
It's going to take 6 months to a year.
Yeah, right.
So we're able to mobilize within a week, get the data, and have the data within another week or two. So that's a big drive that we're going for, and seeing with what we're doing is these new construction, small sections, rapid response, rapid delivery. It's been really, really positive feedback and looks really good.
Well, I mean, honestly, that's the pitch I was making too. Is like almost like daisy chaining. Like if you're going to do greenfield construction or whatever, just boom, like you can do LiDAR today, tomorrow, and just do like a little bit, and like you can almost be up to date with construction.
Yeah, well, that's what we do with the new construction. Is we'll go with you as you complete the line. So we don't have to wait and do 10 miles at the very end, and wait for that to get processed, and that might take longer to process.
Gosh, that makes
mile by mile, stitch it all together, and you're good to go.
And
think about the money savings.
That's huge.
Well, just like I'm just imagining, like even with the visible inspection as well, and if you see a cotter pin or a screw that wasn't all the way done, if the crew is still there, and they can just go back and put that cotter pin in, versus you're offsite 6 months later. Now I need to mobilize a crew to come out on site to fix something, and that costs.
Not only that, a lot of these are all contractors, so you can't just mobilize a crew. You have to do a new contract to just go fix these new things, or if the contract's not done, get a contract extension. So a lot of things at play that this saves a lot of time and money. Really the big thing is time. Yeah,
time, totally. Yeah, one of the things that it's not another contractor utility that uses our LiDAR system. One of the things that they started doing, I thought was really interesting, is basically like whenever the utility is going to go out for bid, so they'll give you like some data, the data that they do have for that line, but the typical in real inspection cycles like every 10 years. Yeah. So like that data could be up to 10 years old. And so what they were doing is they were taking the LiDAR out and they were going and flying all these areas and then using that to bid better.
Yeah.
And so
that's a big thing in construction too, is doing that for bids on, sites and stuff, which I've seen. We don't do a whole lot in construction, but I've definitely seen where that makes sense. You just do a quick flight, boom, there you go. You're really out.
It save you $10,000 and it takes half an hour. Why would you not do it?
Right.
I mean, the utility could do it because, I mean, I think the name of the game for most I'm not speaking for Surefire or anything, but like it's a change order,
Yeah.
Because, I mean, if you make a bid based on 10-year-old data and you get out there on the site and things are totally different, you do need to change like that.
Yeah.
Your bid isn't accurate because the information coming in wasn't accurate. And so, I think these change orders can really add up. So basically, staying on top of things in real time is great.
Yeah.
Well, Noah, why don't we go ahead and move over to some questions from the community?
Sure. Sounds good.
That sound good?
Yeah.
Curtis, does that sound good to you? He gave me a thumbs up, everyone. We're safe. So let's kick off with our first question here. We got Mike from RTR Energy Solutions asks, have you guys flown rope for any transmission work with drones or looking into it?
That's a funny question. So ironically enough, I would say within the last couple of weeks, we are going to be providing that service. We're looking to be providing that service with a new partner.
That's awesome.
So it's something we haven't done, but we are soon going to be providing that. So whoever asked that, if they're looking for it, let me know. We can get some contact. And
RTR Energy. They do.
It's actually, it's something we're doing. It's a great partnership with a company out of Australia, and it's going to be pretty cool. So it's something we are definitely doing. Yeah,
just so everyone knows, that basically, like, if you're gonna pull one of these big ass heavy transmission wires, this conductor, usually you're gonna take a small string. It's logical. You take a small
straw
string
line
first.
Rope.
Yep. And then you run that through, and then you pull that through, and then you pull the big one.
You get the big pullers.
String it.
Yep. Exactly.
So, but using a drone to go from tower to tower, and you just fly the drone with that rope.
Well, because it's not super heavy, you get a proper heavy lift drone, you can fly that no problem. And then you've got the, typically that's done with a helicopter again. And that's the force and the tension that the helicopter has to pull on, just wasting a lot of emissions, a lot of gas going into that. Where drones all electric, you're just pulling it through. There you go. There's a lot of less dangerous too, because you're typically flying around residential areas. It's loud. Helicopters are extremely loud. The noise pollution they produce in residential areas is super annoying. So it really cuts down on a lot of different factors.
So I guess if he wants to reach out to you, can he reach out to you after this?
Yeah, absolutely. I don't know if Curtis, you can put my email in the chat or something like that, but please feel free to reach out.
Awesome.
More information.
Let's go to the next question. So is there a certification or a licensure that Surefire is required to have in order to perform these services?
Yes and no. I don't know. A lot of the utilities require a lot of insurances, certifications, Part 107. Everybody's got to be Part 107 certified. And we make sure internally we have a really in-depth training program that we put together that, allows us to, I think, be certified and, really put together a quality service. As terms of, the utilities, they look for cybersecurity, they look for insurances, it's really in depth. So when I talked about earlier barriers, that's one of the barriers of getting into utility work is just insurances and requirements from utilities for cybersecurity, data management, and a lot of things. If you're just getting into this by yourself, solo, it can be difficult, but it's possible.
Definitely possible.
You just got to have, the ability to want to do it, and a little bit of knowledge goes a long way. I definitely recommend you go after the contractors and the engineering groups. A lot of utilities can be difficult to get into, but those are kind of a back end way to get in and kind of get started that are a little less stringent compared to the major utilities.
I totally agree. Yeah, going right to the contractor. I mean, what's the big one? They're obviously you guys.
Well, we're not. I think I wouldn't say we're a contractor. We don't build anything. We're more of just like a subcontractor per se. When we do stuff. But like contractors like that actually build the lines,
right.
Utilities like Southern California and stuff like that, they're not actually building the lines themselves. They hire out to contractors to build those lines.
Right.
And those contractors have to follow requirements for LiDAR, for inspections, for anything like that. And then they hire somebody else to do those. So it's kind of a trickle down effect. And if you can get down into that trickle, you can get in a little bit easier.
I mean, in this industry, crumbs are very big.
Oh, huge crumbs.
Crumb guys.
The sandwich is billions of dollars, so make a million here and there. That's all right.
Yeah, that's a crumb.
Yeah.
Yeah, but I think in general. So there's no formal license though. There's no like, it's not like being a licensed land surveyor or something.
No,
so nothing like that.
Nothing formal like that. Only in terms of formal license surveyor, ground control points have to be captured and certified by a licensed ground surveyor, at least here in the state of California, with most of the utilities. So we have to subcontract that out because we don't have licensed surveyors on our crews.
Yeah.
That would really be the only license thing you'd have to be worried about.
Yep.
So yeah, in terms of licenses or certifications, it's not super difficult or school heavy that you have to have before you're getting into it. It's just a matter of being able to get the right spot at the right time with the right people.
Yeah, my experience is it's utilities. They move slow, but once they move somewhere, they're there.
So slow, slow. For example, the contract we're on right now with this utility, I think it took almost a year and a half to get things in place before it even got started. So if you're just starting out, you're like, hey, I need work. Be prepared for the utilities to wait a while because there's a lot of bureaucratics and stuff like that. A lot of people that are in charge, that have to get sign off everything. It's like 50 people that got to go through it, so it can be difficult.
Yeah, gosh, it's bringing back.
You're aware,
bringing back some horrible memories.
Man, it was
the juice was worth the squeeze.
It is. At the end, if you get it, it's way worth it. But when you're sitting there for a year being like, man, is this contract ever going to go through? Am I going to have a job?
Right.
Oh, no. It's definitely nerve-wracking. But once you get into it, it's great.
And the utilities always pay their bills, too.
They do pay their bills, yes. They're backed by the government most of the time and typically will pay pretty well. So.
Yep, exactly. Let's jump into the next question.
Curtis was saying something in the chat I missed here. That data set we looked at, our UGCS actually didn't break. It didn't work. I had to fly that whole data set manually.
Oh, that was manual?
That was all manual flight. I flew.
Nice.
So in the heat of the moment, I was like, hey, we got to get this done. Flew that all manually. The difficult part, you're going to 400 feet elevation change, trying to keep your height consistent. If you pull up, I don't know if you can pull up the flight path on that thing, but it's like this going up the hill. But it turned out great. So, I'm not going to complain.
Not going to complain. Yeah, it all works out. Okay. Many of my potential customers are opting to start their own internal drone programs, leaving contracted drone surveyors out of the equation. Can you speak this at all? So I'll say something and let you say something too. So my first thing is that what I saw is so going back, a decade now, coming to now, as I saw it all was like, first of all, no one knew what they were doing. So it was just nothing. And then it all in-house drone programs started popping up everywhere. And then all of a sudden it was like utilities like, we're going to do everything ourselves. But now I'm seeing the pendulum go the exact opposite way where they did do that. And they're like, wait a minute, we're not an aviation company. Yeah. Like, let's get somebody else to do this. So that's what I've seen, but maybe you can talk more about that.
Yeah, I would say it's more of a balance now. Instead of being all utility versus all subcontractor, I would say it's more of a balance where a lot of them do have in-house programs, but they only do a small portion of what needs to be done. They subcontract out a more portion of that, or they've done it. I know one utility out in the desert who bought a $100,000 drone. They're like, hey, we're going to start our own program. And they're like, this doesn't really make sense for us to do. We got to train all these people and do all this stuff. And we don't want to do that. So, you might run into people where they're like, oh yeah, we're going to start our own. Come back, 6 months later, they still haven't done anything, or two, they tried and they failed. So you keep an eye, follow up with those types of customers, because even if you can't be their service provider, maybe you can be a consultant on getting their program started. And, that's revenue still, for however long it takes to get started while you're still working with other contractors to get contracts.
And then inevitably they're going to come to the conclusion that they are not an aviation company. They're in the business of making electricity and selling it, not in the business.
Drones.
Yeah, right. That's not their business. That's not their core competency.
No. You put yourself in a good position, you can capitalize on a lot of those guys are saying, hey, we're going to do our own thing.
Yeah,
for sure.
And that business isn't going anywhere. Like if you build that relationship and maintain it, the utilities are not going anywhere. So
like I said, even if they do start their own internal division, they're not going to be able to do everything, and they'll quickly realize that it's a lot to do it all. So if you're you keep the contact going, then you're good to go.
Awesome. I think we got 2 more questions. Question 1 of 2. I'm looking at performing facade inspections. How would LiDAR work for this scenario? Facade on a transmission tower or
just like a cell tower or a building? What you looking at?
what are we looking at here? What are we looking at?
Harrison's got the answer. He's got a few tricks up his sleeve. He knows what to do.
Let's just guess.
Yeah. Speak each one. All right.
Find these facade. You can do that or use the R360. It's got the 360 degrees, so
yeah. You got the facade mount or the 360. Yeah.
Don't miss. It doesn't miss. All right, let's jump in the
next one. I don't recommend facade mounts for power lines totally because it's a lot more efficient and quicker just to do top down. You're going to get all the data anyways. So if you're doing for power lines, stick with that top down R2A or the R360. But facade, yeah, you're looking more cell towers or what about buildings.
Yeah, right. Last question. What is your drone LiDAR hardware gear setup?
So it depends. We've got a few different setups. We use the M300 RTK as our DJI drone. It's a great bird. I personally love it just because of the battery life and how reliable it is.
How far would you say one?
I don't know.
Battery.
You know what? The community may never find out. We know, but the community might not know.
That's a secret, trade secret.
Yeah,
how far? That was like
8 miles.
That's 8 miles.
It was 8 miles, which I don't know if Daniel. I think this is before your time on here. I'm sure you've heard the story.
I'm seeing the video.
You've seen the video. It's unfortunately it was not able to be posted.
I can show the data set though. I can show the data set.
That was yeah. Go for it.
Let me
share
my
story. There is we went through the desert and we flew an R2A on an M300 for as far as we can go. We were in a buggy and just going down the desert and 8 miles what we got in one run on one battery set.
Yeah.
And Harrison screaming at me not to land it incorrectly at the first time I'd ever flown with an R2A.
Oh yeah. This is your
that was your in-person.
I was like, hey, throw me in the deep end.
This is in-person training. Yeah. So we take off and then we manually flew this too because we were messing around with it doing the.
No, this was programmed.
I
remember I sat there for like half an hour in the middle of the desert plotting points and using Google Maps elevation profile to adjust the height as we went down because slight decline.
Right.
It was perfect all the way up to the last tower where I had to flick it into manual mode and adjust. But I did it for how many towers? That was like 30 towers or something like that.
Oh, I don't know. This is. I feel like I'm zooming it forever. Let's let it load.
That was fun. That was a fun data set to capture.
Wait, so that was it was almost 8 miles, right?
It was 8 miles from what I remember.
Yeah, 8 miles.
I can measure it right now, but yeah.
Don't mind if I do. Give me 1 second.
Yeah, see how that landing looked too. That flight path of the landing I remember it being rough. But hey, the data looked great. So if you land rough, it's okay.
That's roughly the end of the data set. Let me just
roughly
pulling it down here.
Still going.
Oh my gosh,
we flew so far.
It was cool. We were in like side by sides flying. This is all in the desert too.
Yeah.
Didn't I leave the lens cap on too?
You did. Yeah, we don't have a color eyes because you left the lens cap on.
Well, if you've ever worried about if you're the only one who's left the lens cap on,
Harrison's done it. He's done it. You can't blame yourself. If he's done it, you know what?
I've done it too.
Yeah, we've all done it.
All right,
you get it to land and you're like, I gotta go refly that whole data set.
All right.
Nope, the LiDAR's fine.
Yeah.
All right, guys. I think that's we're getting pretty close. We're about 4 minutes past the hour. Noah, it's been a pleasure hearing your stories coming from Best Buy to Best Guy.
Yeah, American dream right there.
The American dream.
Nice.
Thanks,
I hope people learned a little bit about utility inspection with drones, kind of where we're at today and where the BVLOS is of the future with the LiDAR and with inspection. And we got another one coming up on Pi Day, March 14th coming up. I don't know what's going to be about yet, but so
there better be pie on the.
I was about to say,
you guys better have pie.
We should have pie. Okay, we'll have
pie.
We'll do something like this. But again, Noah, thank you. And then we have this use case study that is live now, so you guys can read a little bit more about some of the work that Noah's done on the blog for ROCK Robotic. And Vince just wrote to us. He said we're gonna have warm apple pie. I doubt that. We might, though. I would like that.
Me too.
Send me a slice too. I'm not too far from you, Harrison.
Yeah, I'm actually going to be driving past you. I'm going to go up to Tahoe this weekend, hopefully, and go skiing. It's a lot of snow.
There you go. A lot of snow up there. Stop by. We'll grab some lunch or something if you're free.
Yeah, let's do that. All right, guys. Thanks for being on the podcast, and we'll see you here next time here on Drone Money. Bye.
Thanks, everyone.